Hello, Black Hats. How's everybody today?
Great.
Was that lunch awesome? All right, I'm done. I'm out. Let's drop the mic. All right, so today we're going to talk about Amazon. And how many people, by just a show of hands, have worked with Amazon? I want to see everybody raise their hand. All right, awesome. So we're going to talk a little bit about bringing Machete to the Amazon, what that means, and we're going to talk about the cloud, okay? So first, let me just introduce myself, do the obligatory. I'm Eric Peterson. So I'm primarily an AppSec guy. I've been doing AppSec for a long time, working on a lot of scanning products. And right now I work at a company called Veracode, where I'm the Director of Technology Strategy. And we started getting involved in building things on top of AWS in a big way quite some time ago. And I started playing around with AWS about since 2009. And along that way, along that journey, it was definitely a journey. If you've watched other companies do this, or maybe yourself personally has gone through this journey, you get really excited and you do a lot of very exciting things, and then you do a lot of scary things, and you learn a lot of things by making a lot of mistakes along the way. So I'll be sharing some of that as we go through the talk. As I go through this, if anybody has a question they feel like that just is burning a hole in their pocket, you've got to ask it, feel free, go ahead. If it's a bad question, I'm just going to ignore you. But if it's a good question or a bad question, you can save it to the end, but it's up to you. It's a big audience, so maybe we'll have to leave it to the end, but I will leave room for questions, hopefully. So this is kind of an agenda where we're going to try to talk about just some points. Hopefully this is really here for me to keep on topic, but we'll kind of go through a little bit of an intro and try to ground things, and then we'll end up on things at the very end. And I have the old name for the project, but it should be Machete anyways. So let's talk about how I would like everyone here, for the purpose of this talk or as a security researcher, to think about cloud environments like AWS or anyone else. I'd like you to take a moment out and stop thinking about cloud as SaaS, PaaS, IaaS, blah, 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 my ass, whatever it is, and think about it from a kind of a simpler perspective of cloud being an operating system, right? So think about what you get from an operating system. You get disk, you get memory, you get compute, right? What do I get from the cloud? I get disk, I get memory, I get compute, and I have a way to write code and interface with APIs and manage it that way. And I think this is the fundamental way that we should view cloud environments, as an operating system, not as something, a bunch of virtual machines or a bunch of servers that somebody else manages for me, or a bunch of whatever we want to call it. It's an operating system, and it may be a very advanced operating system, or maybe a simple one depending upon the priority you're using, but it's an operating system. And if you think of it in that frame of mind, and you approach it from a security research perspective, you can kind of change your perspective about how you start to view things. And Windows and Linux, that's just the microkernel of this operating system, right? And so that kind of leads you to think about the infrastructure, and the infrastructure itself, that's the code of the operating system, right? I write a few lines of code, whatever my configuration management solution of choice is. Maybe I use Ansible, maybe I use Chef, and I create infrastructure out of code, and I do that in a matter of seconds. And that ease and the APIs that make that possible are all part of that operating system. And nobody's really been spending time, when you think about it from an operating system point of view, doing very specific targeted kind of testing from an operating system benchmark against this, against the cloud, right? I'm sure plenty of people have been trying to hack into Amazon and all that other stuff, but I'm talking about the whole system, right? So with that kind of structure in mind, let's talk a little bit about the, what you get, and just kind of set some baseline here. So fully realized AWS application probably looks something like this. This is just one fancy diagram. There's lots of different fancy diagrams. But it's a lot of components. All these systems are virtualized. All these systems are created probably in seconds by some script or something that you can write. And if you created it manually through the web UI, you're doing it wrong. But that's okay. We all started there, right? And we create all these systems. And traditionally, when we thought about building up an environment, we were mostly thinking about our applications when we were talking about application security or locking down. But the interesting thing about that is the applications themselves, it's a very small part of the overall system, right? So the Java code that I spent months working on, or PHP, God forbid, or whatever it is that you're creating, and you're putting that, sorry, I have some biases, apologize. So, that you've put into your environment, that's just a very small part of that environment. And it exists in this much more complicated space that previous to something like AWS, you just pretended it worked fine because it was somebody else's responsibility. But as a single individual, you could create all of this and have it done in a day and actually deploy your application in there. But you might not realize that even though you've created all of this, it's also your responsibility to secure and manage all that. And that's the entire system, right? The majority of the system is going to be provided by whichever provider you're using, but let's say AWS. And while they give you all these wonderful pieces here, it's your responsibility to make sure they're secure, to make sure that you're using them correctly, and that when you've hooked them together, that you haven't introduced any sort of emergent kind of chaos into that system, because it can get quite complex. So if that's where I try to go with a nice environment that's clean and makes a really, beautiful Visio diagram, what do I start out with? Well, I mean, this should come as no surprise. You get, from AWS, you get the equivalent of an infinite number of empty racks that you can do anything. It's like that scene from The Matrix where Neo steps out and says, I need guns, lots of guns, right? And just guns start showing up. So every day I wake up and I go, I need servers, lots of servers, right? And they just start showing up. And that was very exciting. That's why I started playing with AWS. The fact that I could go and create 100 systems just by clicking a button was unbelievable, right? And you get a friendly web interface. You get a mile-long list of compliance certifications. And then you show up. You or I, right? The customer. We show up and we put our stuff in it. And this is what happens. We create the digital equivalent of this, right? Or the virtual equivalent of this, right? We started with these grand ambitions and everything was going to be absolutely perfect and clean just the way it started. But a week goes by and maybe you take a break and you step out and you gave one of your developer friends access to the console while you're away, and then you come back and you're like, why are the 300 systems running and what are they named and why do I have 50 launch group zeros laying around and why are all the firewall rules open to the entire internet and what the hell's going on, right? And oh my God, my bill, it's like $5,000. What happened? How many people had that really fun experience the first time where they realized that, you don't even know what I'm going to ask, but you guys are raising your hand, where you realize the bugs cost like real demonstrable dollars very quickly, right? Yeah. I've written a buggy line of code and been like, oops, I just spent $300, right? So you get the digital or the virtual equivalent of this, and if you're like me, you're at some point that guy stuck in there somewhere trying to figure out what on earth have I gotten myself into. And so a lot of people go, you know what, building applications on top of AWS is complicated, there's a lot of services. I'm going to just do the safe route, and I'm going to forklift my existing applications into Amazon, because I've had maybe dozens, maybe hundreds of people working on these apps, and they've got an operations team, and everybody understands everything, so I'm just going to forklift them and deploy them into Amazon. And that's a nice idea, but the problem is that forklifting can also be a little bit dangerous, right? So forklifting is that process of taking a legacy application and moving it into something like AWS. A lot of times it's the most expensive way, because a lot of times we don't realize just how low our utilization of the resources is, right? So sometimes we oversize the systems, but it's also dangerous, right? You take all those existing controls that you've got, your IDSs, your firewalls, your whatever it is that you're using, some fancy SIM product that have been tracking all the events, and you put that in AWS, and it's all wonderful, but it's also completely oblivious to something I'm going to be spending a lot of time talking about, which is the API, and how that is the real controller for your entire environment. The other problem that comes out of this that I'll also talk about is how previously ignored or very low priority vulnerabilities or vulnerabilities you didn't think were really that important to you become really bad things in Amazon. And the meaning of availability also changes, where you had a dozen people who are tasked with keeping a single machine up and running. Like, I like to think of availability in the realm of security. The meaning of availability completely changes. And so it's not about having a dozen people or 100 people or 1,000,000 people all tasked with keeping a single machine running. Availability in AWS is about having multiples of everything, right? You need to have at least 2 machines because failure is guaranteed. And the Netflix guys have talked a lot about this in the past. If you've watched any of their talks where they talk about what they've done with Chaos Monkey, where they said, you know what, it's inevitable that things are going to blow up. So let's just make that process happen a little faster, so we'll evolve a little bit faster. And it's true. Sooner or later, it's going to fail. So that one box that runs in your data center that nobody knows what it does but generates $100 million, you move that into the cloud and you haven't thought about re-architecting it, it's the Titanic waiting to happen. Right? So all this kind of comes together at what, kind of the first point I want to make here, that what I think about is emergent insecurity, right? How many people have ever heard of like emergent properties of complex systems, right? Where these properties come out of the woodwork that you could never possibly expect. A lot of people spend a lot of time trying to test every eventuality, to test everything that they can possibly do before they deploy their software. The problem within an environment like AWS or really any cloud provider is that that environment has a lot of very unpredictable things. One of the things I like to remark on quite a lot is something I call internet weather. How many people have ever heard of internet weather? So I'm going to be the world's first internet weather reporter at some point. Internet weather is, you come to work one day and you're looking at the systems, you're like, everything just seems to be running a little bit slower. Or everything seems to be running a little bit faster. Or this system seems to be just behaving a little bit odd. And it's kind of like, all right, well, in the west region today, things are running a little bit slower, but in the east, it's really fast, and it's going to be a nice sunny day, right? So this internet weather kind of affects your whole system. So now the systems that you've got that were dependent on having consistent access to disk or a very reliable ability to communicate with systems, well, they're vulnerable to internet weather, right? And these kind of emergent problems start to enter into the system, and a system that was perfectly secure starts to have these cascading failures. And if you look at like the most complex systems in the world, things like airplanes or things like that, you'll see this cascading failure effect where lots of little things come together to conspire and cause a very big problem. And of course, the larger you scale these systems, the worse it gets. So internet weather, guaranteed failure, everything is software defined. A lot of people don't build systems with the idea that I can do the virtual equivalent of yanking an Ethernet card out of a machine and plugging it into another one without losing a packet, right? But I can do that within a cloud environment. I can take the virtual network adapter and plug it into another one, right? And then all the out-of-band management capabilities are all happening completely outside of any of the traditional controls. And this, I'm really talking about the API. And the API is everything. It's everything that we need to really concern ourselves with it. So my recommendation on that point and kind of the piece here to kind of put a bow on this is that I recommend that we think about eventual consistency from a security model, right? And this one's really tough because you could say, oh, this just sounds kind of like a perfect world. And I'll be the first to admit there are certain types of systems that are not going to map onto this. But the idea is that you should get your decision loop tight enough so that you're able to respond versus trying to control change. You're able to respond to change. And if you can respond to change fast enough, it's better than being able to control change, because the truth is we'll never be able to control change. And particularly in a cloud environment where the changes are a lot of times out of your control, completely, right? If you try to maintain complete control and your entire system for managing and securing your environment is based on change control, and then you move to an AWS-like environment where your developers might be sitting at that console or internet weather is affecting you one day, you're eventually going to have chaos. You're eventually not going to be able to survive when something does change, and it will happen. Thinking about that, how many people heard about when Netflix like a year ago at Christmas time died, right? Did that happen to anybody? People with their kids and they were screaming. So the year after that happened, how many people noticed any disruption in Netflix's services? How many people knew that they shut off 50% of their entire environment and nobody noticed, right? They realized that they couldn't control change, and so they got in that problem. It bit them really big on Christmas, probably one of the most important times of the year. And they said, all right, well, the best way for us to handle this is to create the most chaotic event we can imagine and accept that it's going to happen. And they destroyed the entire East Coast of their operations. And they failed over the West Coast and nobody noticed. It was amazing, right? Now, granted, that works for a streaming platform where you have millions of users. It's going to be a different approach if you're managing a financial system where you have certain kinds of transactions that have to maintain consistency. So you can't apply this everywhere, obviously. All right. So I keep on talking about the API. And this is the king of the jungle. The lion of this jungle, the lion of AWS or any environment is the API. If we're thinking traditionally about how I'm managing systems and I'm logging into them and I'm setting them up and I'm creating snowflakes and I'm going about things the way I originally did, I'm missing out on a very powerful piece of that environment. I'm also missing out on an entire channel for how that environment gets managed or can be disrupted out from underneath of me. And that king of that jungle is the APIs, right? And that's why, if you spend a lot of time just looking at the AWS console and you haven't delved into what you can do with the APIs or built automation around that, you're missing out on a big part of what makes it powerful, but also what can make it very dangerous as well. So when you think about that new introduction, this new line of the jungle here, you have to ask yourself, what is actually my new attack surface? So there's a really interesting, kind of famous quote from Christopher Hoff where he talked about, if your security sucks now, you'll be pleasantly surprised by the lack of change when you move to the cloud, right? And I would argue that in the reality, it actually gets a lot worse. It doesn't get better. And it's not because of anything that Amazon or Microsoft or anybody did. It's because you haven't spent the time to understand how these things affect you. Internet weather, software-defined everything. And the API endpoints, let's talk about those for a second, right? They're open by design. They trump all existing controls. I could spend a lot of time locking down my machine, and I could come right back in behind it and clone it and disable a lot of the controls that I've created. The public or the private IPs might be public. When I create a machine inside of EC2 Classic, now most people, when they create a new account, they're in VPC, but a lot of systems continue to run in EC2 Classic. You get a private IP address, and you can also assign it a public IP address. And you might think, oh, well, it's on a 10 dot network range. Nobody's going to be able to ever see that. I'll have my admin interface running on that. Well, guess what? If I'm a customer in EC2 Classic, I create my own private system in there. The private IP space is open to a lot of things. I can poke around. And I've taken a very casual look, looking around, and there are a lot of web servers running out there. And so I'll get to that in a second, right? But ultimately, the only thing that's really standing between you and a total compromise of your entire data center is the security or the secrecy of your API keys. And think about that for a second. It's not just that they're going to get access to a few systems. It's that you're going to let somebody get access to your entire data center, right? So API access in the virtual world and in the cloud world means physical access, right? And that's the piece that we have to realize is kind of the linchpin of this whole thing. So what exactly can happen if I have a credential exposure? Well, so pretty common, we've probably heard about people where they go in and somebody gets access to the keys, and the first thing they do is they set up a Bitcoining mining operation. How many people have had that happen to them? 1, 2, 3? Okay, I've been lucky; it hasn't happened to me, but it's very real. And I think that everybody who had that happen to them is actually the luckiest of the bunch, to be honest, right? You had an impact to your bill, but what they could really do is they could go further than that. They could adjust, go in and alter your applications. They could start spreading, some sort of malware. They could use your environment to launch additional attacks. They could download all of your customer data from your environment. I mean, maybe they do all 4 of these things. But ultimately, once they're done with this, they could go in and they could nuke the entire data center, right? And there are companies that have found this out the hard way, who have built environments and accidentally let their credentials get exposed. And some of them just had Bitcoining mining operations, but there was a pretty big case where a company had this happen to them where they lost their entire environment and had to shut down completely, right? So the entire ability for your company to function rests on top of the secrecy of those API keys. So you can guess where I'm going with this. We're going to talk a little bit about how we might get access to these keys, right? So what are some of the traditional controls I can bypass? So let's take an EC2 system, put it in VPC, lock it down, block all the network traffic, throw away the SSH keys, throw away the passwords, just shut everything down, make it absolutely impossible. In the physical world, I would have to actually, at this point, walk up to the machine and do something on the console. Well, you could say that machine is completely locked down, but in AWS, I can just make an API call if I've got the permissions to do so. I can make a call in there, clone that system, open it up. I don't have to have the keys. I don't have to have anything. Snapshot it, mount it to a machine that I do have control of, and then I can extract anything I need or want. And the best part about that is there are no traditional controls that you have in place that are probably going to detect me doing that, right? Same is true of RDS. I've built out my database hosted in RDS. Maybe it's MySQL, Oracle, Postgres. And I don't need your passwords to get to that database. I just need a snapshot. You could have come up with the world's most complicated password of that database. If I can snapshot it, I can mount it and take it someplace else. So as an attacker, if I'm looking at your applications running in AWS or any cloud environment, and I look at that and I go, you know what, I could spend all day with this SQL injection vulnerability that I'm trying to perfect, or I could just find one of these lesser vulnerabilities I'm going to talk about in a second, extract the API keys, clone that database, move it into another account so you don't even see the impact to your bill, and pull out all the data and completely exfiltrate all of your information without you ever really knowing that it happened, right? There's no transactions in your web server. There's no transactions in your IDS logs. There's none of that. I just made an API call, copied a snapshot of your database, and now I have all of your information. So what are some ways that I can get access to the APIs, right? So the obvious big mistake is you can accidentally check in your API keys to GitHub. I would like to believe that that doesn't happen anymore. I did a search last night, and I was really disturbed by what I saw. And I can also exploit vulnerabilities to access metadata. So last night when I was looking at GitHub, I did a quick search for secret access key. And in like the second page of results, there's somebody who's going to have a very bad day, right? It was that easy. So the good news about this is that Amazon and other folks have gotten wise to this, and they are proactively going out there and trying to find this stuff and alert people before it becomes bad. So they are doing the right thing. But this is something that's all too easy to do. So be very careful about when you're checking in your code that you're not hard coding your credentials. It's so easy to do. Almost everybody does it. Thankfully, when you go through a lot of the code on GitHub, you're starting to see a lot of placeholders for things. So it's a suggestion that people are getting wise, or maybe they've just gotten burned by it a little bit too much. But if you want to think about how quickly this can turn from a mistake to really bad, set up an API honeypot. Take an account you don't care about where it doesn't have systems, check in those credentials onto GitHub, and then spend a little time looking at your environment. And within about 60 minutes, you should see machines starting to pop up in your environment. Right? Or did I say 60 seconds? 60 minutes, about 60 minutes or less. It might be 60 seconds. It depends if you get lucky. Right? And it'll be amazing. You'll be like, wow, the power of the cloud. Look, all these machines just generating themselves, except you're not the one doing it, right? And the next thing you know, they're setting up a very effective Bitcoining mining operation in your environment. So that's the best thing that can possibly happen. But how can I get access to this APIs if I haven't gone and accidentally checked it into my account, or I haven't just made some really dumb mistake by posting my credentials online somewhere? And so the first area that I want to focus on is metadata. And if you search on Google for images of metadata, you get all kinds of really cool Metallica-like stuff. I had no idea. The internet is awesome, right? So I love this particular one. So this is cloud metadata, okay? And it is out there, and it's something that we don't necessarily think about. But when I bring up a machine inside of EC2, there's metadata associated with that machine so that the machine can know who it is, what it needs to do when it starts up, how's it going to bootstrap. And if I'm using some of the permissions and policy models that I should be using, it's going to also contain credentials. So what is cloud metadata? So it's kind of loosely based on a standard, RFC standard that was kind of taken for this task. And it does all kinds of awesome things. So I can drop a startup script. So if you ever wondered how an EC2 instance can automatically bootstrap itself, how I can pass a script into that machine when it starts up, it's using a project called Cloud Init that pulls in these scripts, automatically starts up, runs them. And I can put a lot of information into metadata as well, outside of tags and other information. And then it also has all kinds of other data. And it's not just AWS that has this. All cloud providers have metadata to some extent, except MS Azure is a little bit different. They actually have it in a fixed file that lives on the file system. All the other ones provided dynamically through this interface. And interesting enough, I just learned just the other day that while Google has this, they have introduced a custom header that makes it much harder to get access to the metadata, which will kind of make it more difficult to extract metadata from systems and some of the techniques I'll talk about. But at least there's some ideas of how this will improve, and I expect it will improve at some point. But right now, if I make a request to that AWS URL, I just fire up wget or curl, I'm going to get back a lot of really interesting information. And I would recommend that you use the wget or curl, because using the command line tools, you're not going to get everything. So here's just a list of running this wget command, what I'm going to get out of this. And you can see here I've got all kinds of great stuff, what my public IP address is, what my instance ID is. These are all the things that I can't necessarily get to because they're outside of the system. But just running that wget command is going to give me access to all of this. And each one of the ones here that is a folder means there's more data behind that, more information. Now, if I wanted to extract my credentials out of the metadata, if I've assigned a policy or a profile to my instance, what's going to happen is it's going to put that information into a key that's into the IAM key with the security credentials under a profile, and I'm just going to have to do a couple requests to figure out what the profile is. And I'm going to get back something like this. And the data in red is everything that I need to authenticate and get access. Right? I can take that information, pop that into a configuration file on my local machine, and basically I have these credentials now ready to go running on my system, and I can make those API calls with these credentials from anywhere that I need to be. So of course the question you're wondering is, all right, well, so I can run this from the local machine. What else can I do with this? How am I going to get this outside of the machine that I already have access to, right? And of course these keys rotate. I think there's like a 24-hour timeline on how long this key rotates, but I've got 24 hours. I can do a lot of damage in 24 hours. So this is where some of the old vulnerabilities I was talking about kind of gain a new life. Some of the ones that clearly we're still spending a lot of time worrying about, like command injection, but we might not be thinking about server-side request forgery, or even wondering about unintended proxy. All of these kind of lead in a direction of where I can somehow trick the application that I've built to make a web request on my behalf. And a lot of these vulnerabilities are out there, but a lot of times people go, what's the big deal? I can trick the application to go pull down a web page somewhere. Well, remember, all of the metadata APIs are just hosted on a web URL, right? So what can I do with that? Well, some real-world examples of that are, how many people heard about what happened to Prezi? So Prezi is a presentation company that they've created this kind of new way to do presentations. And they have a configuration file, and they're entirely AWS-based. You can upload that configuration file into their environment. It kind of loads it, and you can put URLs in your presentation, like go fetch this image and put it in the presentation for me. So the attacker was actually chasing a bug bounty, very responsibly disclosed this, figured out, oh, I'm just going to go and create a presentation that has every single metadata URL and information request that I need. And I'm going to put that in a presentation. I'm going to upload that to Prezi. And within seconds, he got back a presentation that was perfect. It had all of the private data of the instance that was running, right? And he did this because he was able to exploit one of those vulnerabilities I just talked about. At Black Hat in Vegas this year, Andreas Ranchero, he published a technique similar to this using a server-side request vulnerability. Or request forgery, so where he could go in and do the same thing. He was testing an application, figured out he could trick the application to request a URL, requested the metadata, pulled that back, and he had to actually take it a step further. He found out that they had tried at least to lock down the policy associated with those credentials. So all I could do was inject a SQS message into the query queue system that AWS provides you. And then he had to exploit a Celery Python vulnerability. But once he was in there and he had API access, it was only a matter of time. And as you start to look, you start to think about these vulnerabilities that are lower priority, or ones that we haven't necessarily been looking at because we've only been concerning ourselves with SQL injection and cross-site scripting. If we haven't been thinking about these types of vulnerabilities, the ones that are maybe not as exciting, when we move to the cloud, we could be in for a very rude awakening, right? So what are some of the things that I can do to control API access? Well, there's not a whole heck of a lot. Now, if you're using Google's environment, because they have a custom header, it's very hard to forge a custom header into a request to do that. So that's going to stop a lot of things. But if you're in AWS, the only control I really have is I can specify a source IP address when I apply that to the policy that I've created or I assign to my API credentials. And I can assign a source IP, and one thing I might consider doing is assigning the source IP of the VPC gateway that's being used in my VPC environment. You can't lock it down to just, I'll just lock it down to 10.1 private IP address space, because anybody else in AWS can fire up a machine in private IP space and make that same request, right? So that's one control you can do. I think this is going to improve in time. I'm sure that AWS is going to think about how to lock this down. And I think what Google's doing is going to try to become a standard. It doesn't necessarily eliminate the problem. If I have a command injection vulnerability, I can still get access to that information. And once I figure out as an attacker that you're running in AWS, the first thing that I should be going for is not any of the other vulnerabilities. The only thing I care about is getting access to your metadata, because that's ideally going to give me access to a lot of systems in your environment. And of course, I need to make sure that I'm locking down those policies, and that's one of the other problems that I see quite often, right? So how do you detect if this is even happening, right? Well, for a lot of people, they use their bill as their IDS system when they move to something like Amazon, right? They're like, I got a really big bill. Something bad must be happening, right? That became their intrusion detection system. And they might not get that bill for 30 days. All these people have been extremely lucky, right? So my ask is, please don't use your bill as an IDS. Ask yourself, am I doing anything to actually detect or know what's happening in the background when these API calls are being made? Am I monitoring this side channel that's occurring in my environment? And there are a lot of things you can do there. First, you can turn on CloudTrail in AWS. How many people have played around with CloudTrail? So turn this on immediately, please. Everybody should have this turned on, and I think it should be on by default. The moment you start a new account in AWS, you should turn this on. You need to turn it on in all of your regions. It'll start storing all of the access requests that are happening to your API, all the API calls and everything. And it'll start storing it in a bucket, S3 bucket of your choice. And you can say, I'll just keep 6 months worth of data, or however long you want to store it. You can use something like Logstash as an open source solution to track and monitor all that information. You can go out and buy a commercial solution. But if you're building a system or trying to detect intrusions in your AWS environment and you're not looking at your CloudTrail records, that's a huge problem. That's a huge mistake. So absolutely, please turn that on. But once you've turned that on, you're starting to watch it. Now you've got to really turn your attention to what I call as excessive lack of access control, which is where you've got developers creating policies like this, right? How many people have been like, I don't know why it's not working. Well, just open it up, right? I'll just open up more permissions. Just open. We'll get back and we'll fix that later. It's just the API. I'm not giving anyone the keys, right? Well, this is the absolute worst thing you could do. I've seen people who are like, I'll lock it down and I'll block a few services, but then they allow people to access IAM. Well, I can create user accounts all I want, right? So I can create new permissions. So this kind of excessive lack of access control is kind of part of the DevOps culture, which I love, because I think it's all about getting stuff done. But as we give developers who don't necessarily have a great track record of security because they've been focused on building great stuff, bring them into this environment where they're often predisposed to just making it work, you start to see a lot of policies like that. And when I've looked at a lot of AWS environments, and this has happened in every AWS environment that I've looked at, where you have some developers who are new to it, they start creating this stuff, they start using the wizards and the automated systems, and they start creating these policies that are basically open completely. And there's really no way to audit all that stuff. So it's on us to kind of guide the folks who are using this and keep DevOps powerful by not allowing the developers to kind of shoot themselves in the foot, or ourselves if we're the ones playing around with it, and realize that API access is actually the most important thing that I should be concerning myself with, not spending years trying to make sure that the IP tables rules are perfect, right? Or my security group rules are perfect. Those things are important, but if I haven't locked down my API, they're all easily bypassed. The other piece of information that we sometimes need to think about in terms of where data can leak out of my AWS environment is tags. So tags are something I can assign to pretty much any entity in AWS. It's a really wonderful tool. It's the only way you're really going to be able to make sense of stuff, because everything has got complicated ID numbers associated with it that you're never going to remember unless you're Rain Man. And so you can use tags to assign stuff, but realize a lot of us are probably also using third-party services that help us manage AWS. Maybe we're using something that helps keep track of our bills. Maybe we're using something that starts up systems like RightScale or whatnot to help me create environments. Well, they have access to all the tags. Maybe I'm using a permissions model, and I can do this in AWS. I can define a policy that defines who has access to what based on tags. Well, what I've just done there is transition the security rights to whoever can create and change tags. Because if they can create or change tags in my environment, now they can create or change the permissions in my environment effectively. And I've seen people put a lot of very interesting stuff in here in tags. I've seen people put passwords in here. I've seen people put API keys in here, thinking, oh, this is just going to stay within AWS. Those are some of the most scary examples. That information can leak out pretty easily. So I talked a little bit about this just to explain just kind of how that works. So if I'm running in EC2 Classic, and really the way to get around this is you should get off EC2 Classic and get into VPC. But for example, let's say I'm on a system and I say, tell me what the IP address is for a system that I've created, and maybe I've given it a nice C name. It tells me, oh, it's an alias for this other site. And then I go into Amazon and I say, well, what does that site resolve to? And if I make that DNS resolution inside of Amazon, Amazon does something extremely helpful, which is it translates it to the private IP that I can use so that when I'm doing my network requests, it's routed within Amazon's environment, which is great because that traffic doesn't have to go over the open internet. But I now know that this server is listening on that private IP address. Now, why is that useful? Well, a long time ago, we used to see vulnerabilities where a lot of debug information used to escape. We used to see a lot of extra error messages or details like that, and then people started saying, I'm going to turn that off. Whenever the web server is listening on a public IP address, I'm going to make sure that it doesn't give any detailed error messages. But for a private IP address, it's probably a developer using that system, so I'm going to cough up all the goods, right? Still happens today, and I can tell you, looking at some of the systems that I saw inside AWS, that they're in that same ballpark. They're giving up a lot more information, or they're administrative interfaces that they're not expecting the entire world to have access to. Granted, if I have my web server behind ELB, I'm going to get the ELB IP address. That might not be very useful to me. But if I do manage to get the actual IP address, that's going to be very useful to me, because that's where I'm going to start my attack. It's not the public side. I can just spend all day going over the Amazon network, very high speed, pen testing that private interface. There's also an opportunity to leak things out of other services. So looking at AWS buckets, there was some research that was done a little while ago. About 1 in 7 buckets out there have absolutely no access credentials on them whatsoever. It's completely open. That's probably intentional for a lot of them. But just taking kind of a cursory look at some of the stuff out there, I think actually it's an example where it's just excessive lack of access control. With EBS, sometimes I don't think about how easy it is to just clone a system. I mean, how many times have you had a system in Amazon where it just destroyed itself for some reason? You're like, I can't get it to boot. How am I going to get access to it? Well, the answer to that is just snapshot it and mount it to another machine that does boot. You can easily get access to it. Well, I can use that same method of attack if I've gotten access to your environment to clone any machine. I don't need your SSH keys, right? I can get around that if I enable EBS encryption. And you might not have turned on EBS encryption because you were thinking, they've got the keys, so I don't really, is it real encryption anyways because they've got the keys, and what difference does it make? Just turn it on. It's not going to impact anything. And it's actually going to prevent this type of cloning of the environment, particularly if I want to take that out of your environment and bring it into my own. And it's a very easy flag that you can turn on when you're creating an EBS volume. So all of that comes together to kind of call what I call here the full stack hack, where you have a lot of these little different pieces of information or leakage, where I've got private IP space, which gives me an administrative interface. I can find vulnerabilities more likely in that type of interface. That gives me the ability to extract metadata. I can go from there to find API keys that let me create other accounts or maybe clone additional information or clone your database. And I can do all of that outside of the traditional world, right? Again, not spending any time banging on the front door of your application where you've got all your defenses, all your logs, everything that's managing that, pointing at that environment. So to get a handle on all of that, to kind of help people who are using AWS better understand what permissions they have in their environment, I started working on a tool, and it's got a great name and an image, of course. And the idea was to give people the ability to kind of enumerate some of this data so they could see what's going on. And to do it in a very automated or programmatic way so that I don't have to spend a lot of time looking at a web UI. Bring that information a little bit closer. And there's a lot of big systems out there. There's a lot of people who created things. Amazon's got a couple tools. I'll talk about a couple other tools that are out there. So this isn't the only thing that's out there. But I wanted to make my life easier on a couple things. The first thing is I wanted to be able to analyze all of the IAM permissions and really understand what does this user or this key actually have access to? What can it touch and what can it touch, right? The other piece was I wanted to be able to record all the services and things that were in use, so I could start to understand what are some of those connections between the environments. And then I also wanted to be able to crack open these AMIs and EBS images quickly and extract as much information as I could from them if I ever needed to. And of course, the last part is coming soon. I'm sorry. I'm still working on it. So I have a couple screenshots of the system. There's not a fancy interface on there, but I wanted it to be something I could script and control. So this is just an example of doing some permissions analysis where I'm extracting all the keys. It's not going to make a lot of sense. It's a lot of tiny text. But this kind of output is the kind of thing where it's going to come back and say, okay, this user can access these things, or these systems can all be accessed through this user, and start to connect those dots together. The other piece is basically pulling all the resources together. And the piece that I wanted to make also incorporated into this tool is the ability to track change, right? After the fact. So it can interface with CloudTrail logs if you haven't even been running that. You just started that's great, but if you've had those running for a while, it'll pull that information in. So you can see what changed when based on how this system is extracting that information. So I can see here that the EC2 system transitioned from running state to stop state on this time and whatnot. And I get that information out of a lot of other tools. I can get that out of the AWS console, but after 14 days or a couple hours, that information can be gone, or I have to go digging through the CloudTrail logs. So I'm really trying to make this information more at your fingertips. And there are certainly other tools out there, like Netflix's Security Monkey, and a whole bunch of open source stuff. That's very good at tracking resources. I think what you'll find very interesting, the tool that I'm going to hopefully release very soon here, is its focus on IAM permissions and really defining exactly what a user can do or can't do and what resources and systems it has access to. If you have a higher support level within AWS, you also have something called Trusted Advisor, which provides a lot of good information to give you some auditing tools for your security groups as well. And then Andreas released his Nimbo Stratus tool, which was designed to kind of exploit that very specific vulnerability he found to extract metadata. He also has some IAM things there as well. It's worth checking out. Some good stuff. So you guys have been a great audience. I hope this kind of broadened your mind to think about when you're building an AWS environment and how you would go about that. I want, if anything, for you to come out of this is to, one, hope that you have a luck dragon in all of your clouds. But two, think about the API. Think about what's possible with that. When you're forklifting your applications or bringing them into an Amazon environment, don't just think about the traditional controls. Realize that you've got this big hole that you can drive a truck through, basically, and spend some time trying to lock that down. Any questions, folks? Sure.
On the compliance side and the logging, I think there's some false sense of security around the PCI and HIPAA because they don't do anything under scope of compliance beyond data center and network.
Yeah, so their environment is perfect until you show up, right? And then you start putting your stuff into the environment. So all those certifications, a lot of them go out the window the moment you start deploying your apps. Some people have considered like, oh, Amazon's got PCI certification, great, I've got PCI certification. No, it doesn't work that way, right? They've gone and certified their empty racks, essentially, as a place where you can build a PCI certified environment on top of, but you've got to do the extra work to make that a reality, right? And you said you had a second question?
Yeah, privileged access management. So, you have to think about the internal threats as well. What about all of Amazon sysadmins that share one account? I've heard that their access isn't fully logged and they have the same passwords for all group.
Well, so I do know this is that if I turn on CloudTrail, I see every access to my environment. And
That's only API though, right?
well, so everything goes to the API. The web access, so when I'm on the web console, it's going through the API. When I trigger any service or anything like that, it's going through the API. So there's nothing that can be accomplished outside of that API. So so I don't know that for a fact. That would be a question for AWS. I certainly haven't seen anything in the years that I've been doing it where I'm like, who did that? I mean, you'll see stuff like an EC2 system being rebooted because you have maintenance events and things like that, and you'll see an event where, okay, this machine has to be rebooted because whatever, last couple weeks, a whole mess of machines got rebooted in AWS. So you'll see those kinds of events or where systems have to get restarted, but I've never seen anything that would suggest that that's possible. But it's worth asking. We should trust but verify, right? So, any other questions? Awesome. You guys have been a great audience. Thank you very much. Really appreciate it.